Hello everyone, thank you so much to this session of data visualization in Python using the Matplotlib library. So I think this session is going to be exciting and we'll learn the basics of data visualization. After this we'll go to Seaborn and Pandas and Plotly, and we'll learn how to make cool visualization in Pandas. So what I have here is Google Colabs. So I'm changing the IDEs so that you can learn how different IDEs work. So right now I'm in Google Colabs. It's online, so you don't need to have fancy hardware. You just need to have a Google account. Then go to google.research.google.com and you'll be taken to Google Colab interface. So let's get started. So first of all, we would like to import the Matplotlib library in Pandas. So it has got another method called pyplot, and we will import it as a PRT. So we need to reference it as PRT. Then click Shift Enter. Depending on your internet, it's going to execute fast. So we need to write percentage sign here, Matplotlib inline. So basically what I've done here, I just want that Matplotlib should be should actually display the things that we want to display, the visualization in line into our Jupyter notebook. So we don't want it to display it somewhere in another window. We just want it to inline. So this is how you do it. So if I click Shift Enter, it's going to execute, and here we go. We do have a problem here. It's saying mat. I've just light map. Here I need to write Matplotlib, and here we go, we are done. So let's import our favorite library, NumPy as np. So you see there are some other suggestions here, make sure you use them. So when I import NumPy as np, I just want to create some dummy arrays. So I'm using the lean sparse method in Matplotlib, and I need values from 0 to 5, and I need them 11. So you see we do have some suggestions right here. Then I also need an X array which has got values from the X array, but I just want to make sure that I've cubed the values, and Shift Enter, execute it, and we are done. So if we want to check the values from X, you see there are 11 values, but from 0 to 5. That's right. And Y values, these values, they are in the ranges of the X values, but multiplied by to the power 3. So you can see right here that we have put them to the power of 3. So let's learn how to build the visualization using Matplotlib. There are two ways. The first one is called functional method, the one we are going to learn right now. And the other one is object-oriented method. So we'll learn that later on. So on the function method, we call the PRT library, the Matplotlib library, .plot. So it has got a method called plot. So if I say plot here, I will just put the values X and Y. And if I say I want my line to be red or something, I just need to add another argument and say R, and dash here to emphasize that that is a straight line. If I click Shift Enter here, let's see. You see that now with a simple line of code, I have been able to plot the graph here. So if I say I want to have labels, I'm gonna have purity dot x label. So my x label in this case is the x array, so I just write x label, and let's put purity dot y label, and in this case that is my y label. We'll put here capital L. But however, if you are not using Jupyter Notebook, in order to show this visualization, you need to call purity.show like this. If I click Shift Enter, you see it's going to display, but it's going to display like just a document. So it's the same thing. You can actually call the purity show right here. So you can see that we do have labels, the Y label and the X label right there. Now let's see how we can have subplots in Matplotlib, not functions, but subplots in Matplotlib in the function method. So function method, how we can have subplots, different plots in the same canvas. So in this case, we call the method from purity.subplots. So the subplot is just it automatically creates its own canvas. So for example, if you want to draw two graphs at once, you can create that two canvas. So the first argument in this subplot is the row. So we want to have one row, and in that one row I want to have the second argument, two columns. And what I've done here, I have automatically created the canvas. Now what's next? I need to tell Matplotlib that in this case I want to plot my graph in the first column. That's it. So what will happen here? I'll just write purity, the same thing, plot, and go to this side, x, y, and let me put here r, like so, without even putting the dash, because it's by default it's a line. So this is the first plot. Then let's go to the second plot. So like purity dot subplot, and in this case I'll also emphasize the same thing, one row and two column, but I want to plot in the second column right here. So just write purity dot plot, and in this case let me just put things vice versa, and right here, and make the color to be blue. If I run this cell, let's see the output. You can see I do have two plots in this case. So if you are creating maybe different plots at once, you should use this method. Now let's learn how we can plot using object-oriented method. Now, how can we actually build this thing in object-oriented method? First of all, you need to have the figure object. You need to create the figure object. In this figure object, we can have different capabilities that we'll look later on. So in this fig object, I will write fig is equal to, it's just a variable, fig is equal to purity dot figure, like so. Now, once I am done with this, I need to make sure that I have created the axis. So we have just created a figure. A figure is just a placeholder of our documents that we are working in, the visualization that we want. Now I need to create axis. Let's see how we can do that. So I'll have a variable called axis. Then I'll put the figure object. We'll access the methods from this figure object. And let's see, with one of the method is add axis. So add axis, and this add axis accepts a list. So let's take, for example, this list will accept numbers from 0 to 1. So it's just like coordinates in arrays. It's just like that. So if we say here 0, 1, so the first number here is the left bottom. It's the point where we are starting from, the left bottom. So it's like we are starting, at least we shift 10% from the left bottom. That's why it's called 0, 1. Not the 0, 1%. I don't know how this thing. Like, I think it's I don't know. Is it 10%? Let me know. I think it's 10%. Now, if we go here and say 0, 1, 0.1, we are also shifting. First of all, the first element is from the left, so we are shifting away from your left in 10%. We are also shifting from bottom with 10%. Then this third argument is the height. So we want 50% in respect to the canvas, and we also want 50% width in respect to the canvas. So that's how we can create the axis. Now let's plot on this axis. So if I say axis dot plot, and let's put here x and y, and let's add some labels right here. We want to make sure that our plot works better. Now, because you are in the object oriented, you don't have the x label in order to put the labels. You need to set x label. Yeah, that's the changes. I don't know what they meant to change the syntaxes, but that's how it's done. And in this case, we also need to have axis dot set underscore y label. And let's also set a title. So you are now seeing how powerful these things are. So we can set titles. So you can go crazy with this object-oriented method. So this title, I'll just write my title. Like so. Let's execute this file. So it's taking a little bit of time because of creating this figure and axis and so forth. And also I think it's because of my internet can be a little bit misbehaving. All right, we do have the output. This is the output that I was talking about. So let's take a look on how this figure is in reference to the axis. You can see it has shifted 10% from here to here, another 10% from here to here, and this height, this figure here, you see it's 50% to the canvas, and that's why we have like it's small right here. That's how figure objects are. So you can create very huge figures that you want depending on the axis that you prefer. So that's how you can actually work around with these things. Now let's say we want to add to go crazy with these figures. So let's do another figure. So if I say fig2 is equal to purity dot figure, like so, then I need to maybe I want to add two axes. So if I say axis 1 is equal to fig2 dot add the axis, add underscore axis. Remember, it accepts a list. So if I just say 0.1, here's 0.1, and here's 0.8 because I want it to be big, and 0.8 like so. Then let's add another axis. I want to show you how this is going to affect the underscore axis. Remember, they are lists. So in this case, I just want to make it smaller, 0.2, and I want to shift it a little bit so that we can see it. 0.4 and 0.3. After adding axis, I need to plot these axes. So just write plot and let me plot x and y. So in axis 2, I want to plot y and x. So I can go crazy right here as well and change the colors. So go here so that we can differentiate. So let's put axis titles. In this case, we set title. Remember, we are in the object oriented, so we put set title. So in this case, my title is going to be first plot and axis 2 dot set underscore title is going to be second plot. Now let's learn this to see what will happen. Now this is amazing. This is something that we would like to see happening. If you see this, you can be able to reference to what these add axes are all about. I already said that in this case, these two values, they are talking about the size of the plot. These ones, according to the positions, are affecting the positions of the plot. So you can be able to appreciate to how this thing is affecting your plot. So make sure you play around with this and get to know how it's done in this case. Now, we have already talked about how we can create subplots with a function method. Can we also do that right here? Can we also create subplots in the object-oriented method? Yes, we can do so. So there is a certain thing called the tuple unpacking. Tuple and packing. This is also excellent because it's used in a lot of ways in machine learning as well, tuple unpacking. So in order to express tuple unpacking, we go here, fig3, and we say axis. Let me just say axis 4, like so. And what it does, it's like the object releases two values, and those two values are stored in the fig3 variable and the axis variable. So the first one is the figure object is stored in the figure 3 variable, and axis 4, it will store the axes that we want. So in this case, we could is equal to purity dot subplots. Subplots, and inside that subplots, we actually emphasize the number of rows and the number of columns. And in order to do so, we just say n rows, and I want the number of rows to be 1, and number of columns to be 2. You just move this on the way, is equal to 2, like so. Now, let's take a look of what it does actually. So if I learn this and wait a little bit, you see that it has created these things for us. So let's see if I want to create something crazy. So let's say number of columns 4 and number of rows 4. Let me run that one. You see now we can create different layouts, and with this, trust me, you can have visualization of a lot of things at once. So don't worry about these plots that are like they're mixed together. There is a method called parity.typelayouts. Type layouts. And a function, if I learn this, it's going to fix that one. I think I have put type layouts, no type layout, it's just the syntax. So it's going to fix automatically the lines. It's going to do a good job of fixing this, so you can see it has fixed it for us. So it's a good practice that you always do this. So let's get back to our visualization. Let me put here 1 and here 2. Learn this and we'll be able to have 2 visualization. Now you can actually create this if you are doing a project. You can actually create this at first hand and just be referenced. We'll see how we can reference. But however, these values, they are just arrays. This axis is just an array with this visualization. How do we know that? Let's see. If we say axis 4, remember that one, bracket notation, and access the first array and say plot and put here x and y, and let's put a little bit of color, and let's say here we just want to set the label on this and say plot, not plot but set title, and this title let's just put first plot, and let's run this. See, it's able to detect that. Okay, let me copy and paste the second, and let me put here 1 in order to access the second plot. So let me just put here second plot, and let's run it here. You see, we have actually plot on this second plot. So let me just switch these values. Put here x so that we can show the differences. Now this is amazing because, as I already said, you can actually create different subplots and be referencing to them as you go down the line. So let's take a look on how we can create, how we can actually play around with the figure size and the dots per inch. So dots per inch, there's something like the resolution that we want. So for example, if we go here and say figure size and dpi, which is dots per inch. So let's create another object. Which object I created here? 4. Let me create figure 4 here. So it's a purity dot figure. Then inside here we can actually explicitly say the figure size. So we can just say figure is equal to, it accepts a tuple. So in that figure size, we can actually say 3 by 2 inches. They are in inches. Then I also want to explicitly say the dpi. So I say, okay, my dpi is going to be equal to 300. So they are dots per inch, so there are lots of them. So if I say here axis, just x is equal to fig 4 dot add axis, let me just put here 0 0 because we want to start at the beginning, and sorry for that one, 0, and here 1 and 1. I want to have the full width. If I put it here like so and say plot to x.plot, and let's say here x and y, let's learn this one to see how it's going to show. Right, cannot put single artist on this figure. Okay, let's see how we can solve this issue. So without even putting the figure size, I actually put figure here, so it's going to, it should be fig size. So let's learn this and see. Yeah, so you see it has taken the full aspect ratio right here, and it's looking good than this right here. It's looking good than this right here. In here we can also actually say the dpi to be maybe 600, but the more the dpi, the more you are increasing the CPU usage of your PC. So if I land this, let's see, you see now it looks amazing. Wow, how cool is that one? So it looks amazing, and this one doesn't look amazing. This one does. That's how you can change the DPI. So you can play around with the DPI if you want. You can also change the subplots and whatnot. If I say, let's go to the subplot here, and we can change the DPI of the subplots. If I say in this subplot, I also want to change the fig size, I can just say fig size is equal to, let me put here 8 by 2. So 8 inches by 2, and I also want to increase the DPI to 600. Let's learn this one. It's going to take much of the CPU, but it will show. So you see, it has increased the like the resolution of my plot, and I'm able to see and visualize how this thing is done. Now let's see how you can save that picture. So let's see, put here saving the figure, and in this case I will just because I'm in fig number 4, I think, yeah, and just say fig 4 dot save fig. Then in this case just put the name of the figure, so my fig, then add the extension, so just put png. It's able to save this file as png. If I click shift enter here, it will save it to my directory. So if I go right here, you can see I do have a file here, a fig file. Right, you can, if I double click it, you see that it's the document that I was working, because it's very huge. That's why we can't be able to see how to play around with that figure. So we can't, it's very huge. This is just a preview. This is just a preview. We can't actually see it properly, but it has saved in my documents. Now let's see how we can create legends. So this is the last part. So how we can create legends, we have a fig 6 is equal to prt.figure, and let's put axis axis 5 is equal to fig 6 dot add underscore axis, and let's put the list of the dimensions of our figure. Let's put 1 0 0 1 and 1, so that we should have full view. In this case, let me show you something that it's very exciting. If I put here axis 5 and say axis.plot and put x times x to the power of 2, and let's say the label here, and the label should be squared. Yes, you can actually do exactly what I've done here without even setting because what we're doing here, we are creating legends. Okay, let me just remove the labels first so that I should show you how this thing is done. So I also put here axis 5 dot plot and put here x, not the x but y, and y cubed, like so. If I run this file, so after that we can be able to visualize the changes that are here. So you can see there is you can actually see there is a change here. Let me just put here like x so that we can have the same referencing. I think it's not showing well. So you can see there are two plots here, but are plotted not on subplots but in the same diagram. So in order to do this, we need to put legends. So I will write axis 5. There are two steps that we need to put. So I write axis 5 legend, just like so. Then add labels here. So labels is equal to, so I can just say squared. Then right here, let me add labels. Is equal to cubed. Then learn. And let's see how it's happening. We do have an error here. I keep on making syntax errors. It shouldn't be labels, it should be label. All right, after it's done, it will be able to put and show the regions right here. You're able to refer to this and say the blue one is the squared one and the orange one is the cubed one. So that's how you can work around with these regions. Anyway, this is the first part of visualization. So we're able to learn how we can actually do visualization. So this is like the simplest way to do it in Matplotlib, because when we go to Seaborn now, that's where we are going to go a little bit advanced, and I believe you actually prepare for that session. But anyway, thank you very much, and subscribe and like this video. See you